Hi everybody, welcome to another video in statistics, section 8.2, distribution of the sample proportion. So in this section we'll still looking at the distribution of the sample, but this time we focus on the sample proportion, meaning that a percent of individual in the sample will have a certain characteristic. So first, I suppose that a random sample size n, so n is always the sample size from the population in which either each individual does or does not have a certain characteristic. So in this case, let's say in the population, the characteristic is that the person will have a stronger right-handed, favor right-handed. So in that case, of course, a person might favor the right hand, some favor the left hand, and very small percentage of the population can equally on both hands. So in that case, we still consider that, let's assume that will be characterized as the person with the right hand favor the right hand as well. So regardless, either individual will have or does not have that characteristic. Right. So the difficult in this section, the previous section, is the notation and what actually meanings. But after we have everything, after we calculate the mean and the standard deviation, we find a normal CDF, and the rest will be very simple. Right. Now, suppose that a random sample size n, right? We define the sample proportion is equal to x divided by n. Once again, n is sample size and x will be the percentage will have some certain characteristic. X will be numbers of individuals have in the sample which specify characteristic, and n is the sample size. Right, here's an example. Professor Zuro surveyed random sample of 420 statistics students. The results show that 252 students say yes. On the question, will you take another mathematics class? And so we say x is equal to 252 and find the sample proportion p hat. So the p hat is x divided by n. So just divide 252 divided by 420. And 0.6. So that is the sample proportion. So 60% of that sample will respond yes to the question, will you take another mathematics class? Here's some notes. As the size of sample size n increases, the shape of the sampling distribution of sample proportion become approximately normal. Right? So large number. When n increases, the sampling distribution of the sample proportion will become approximately normal. The mean of the sampling distribution of the sample proportion equal to the population proportion. So the mean of the sample proportion, the mean of the sample proportion equal to the mean of the population proportion. The standard deviation of the sample proportion is decreased as the sample size n increases. So bottom line is we will calculate the mean of the sample proportion and the standard deviation of the sampling distribution of p hat. Right, but all of that we require the shape to be approximately normal, meaning n times p times 1 minus p have to be greater than or equal to 10. So the shape is normal, approximately normal, so we can use the mean and standard deviation and the normal CDF. When sampling from the finite population, it is assumed that it is verified by checking the sample size n is no more than 5% of the population. look at this example. Smith is a well inspector at the shipyard. He's known keeping track of good and substandard wells. That from the afternoon shift, 5% of all well will be done substandard. So this 5% here is for the population. If Smith checked 300, so this is the sample size, and from all 7,500, so that is the big N. What is the probability that will less than 20 substandard? Be less than 20. Right. First of all, let's check on the assumption. N times P times 1 minus P. N is 300 times P and P 1 minus P. 300 times P times 1 minus 0.05. Alright, it is 14.25, which is greater than or equal to 10. So yes, this will have the bell shape, so it is approximately normal. Of course, and then we also check the sample size 300 out of the population of 7,500. So this is less than 5% of that, which is good. Right, now with that, we calculate the probability. Right, now probability using, because this one approximately normal, we're going to need the mean of the sample proportion and the standard deviation of that. So first, the mean of the sample proportion is equal to the population proportion. And the standard deviation is P times 1 minus P divided by N. So 0.05, 1 minus 0.05 divided by N, 300. So we have 0.01258, right, about that much. Right. Now, it is approximately normal, right? So we will have the normal curve. We know the mean now is 0.05. And the question here, we want less than 20, because we have to convert this. The p hat for that particular sample, particular proportion of that sample, is going to be equal to x divided by n. So for that particular sample, p hat is equal to x divided by n, 20 divided by 300. 0.6666. And so this one we want less than that, so p hat is less than this. So if we're going to draw this in the normal curve, the p hat here is 0.0667 and it's less than that. So we have, this is just normal CDF where we can calculate the mean and standard deviation, but the boundary from the left, let's go from -999, at the right of 0.06667, the mean 0.05, standard deviation 0.01258. Standard deviation, normal CDF -999 and upper 0.066667, right? The mean 0.05 and standard deviation 0.01258. Calculate, and we have about 90%. Right. So again, just like last problem or last section, we need to calculate the mean. Not in that case the mean of the mean on the previous section, but bottom line is normal distribution. We need the mean and standard deviation. After that, to find the probability, we just need the boundary from where to where. But we need to calculate the mean and standard deviation, in this case of the sample proportion. After that, it's just a normal CDF. Right, let's look at another example. The U.S. household market estimate that 31% of all household purchased in 2019 were considered investment properties. So this one is the P, the population proportion. Now if a sample of 800 homes in 2009 is obtained, so N is 800. Find the probability that at most meaning it equal that or less, right? So we say x is less than or equal to 250, and then from this information for the sample, we can say that the p hat, the proportion for that sample, for this particular sample, is x divided by n, 250 divided by 800. Is 0.3125. Right, so we know actually this one less than or equal to, so we can say what we need is p hat less than or equal to 0.3125. Now first we need to check to make sure that it is normally or approximately normal. So NP 1 minus P, N is 800, P 0.31, and 1 minus 0.31. And that is 171.12. Of course, that's greater than or equal to 10. So that's good. So this is approximately normal. Of course, we also check that 800 homes consider with all the homes in the United States. So this is, of course, that 800 is less than 5% of the whole population of all the houses in the market. So that's good. So approximately normal. So with that, we calculate the mean of the pH. Which is equal to the population proportion. And now the standard deviation of the pH. P 1 minus P divided by N. P is 0.31. 1 minus 0.31 divided by N of 800. Sorry. Square root fraction 0.31 times 1 minus 0.31 divided by 800. We have that 0.01635. 0.01635. Right. Now with that, we know it is approximately normal, so we can draw the normal curve. And we know the mean is 0.31. And this one we want the proportion less than 3125. And we find this area less than that, also be on the left. So just normal CDF from a very small number to that, and where we have the mean and standard deviation. So normal CDF from a very small number to 3125 to that, the mean of 0.31, the standard deviation 0.01635. Negative 9999, 0.3125, and 0.31 for the mean, and standard deviation 0.01635. Sorry, forgot to hit enter. Right. 0.01635. Right. So that's about 56%. Right. So bottom line is this section and the previous section, we're talking about the sample. And the sample, we have the sample mean or sample proportion. Both of them will be can be done using the same normal distribution with some certain assumption. For this section, the assumption is that have to be greater than or equal to 10, or the sample have to be less than 5% of the population. And after that, it is approximately normal, so we calculate the mean and the standard deviation. With that, to find the probability, we just need to know the boundaries, the left and the right end, so we can find area. Right. Pretty much like what we have in the previous section, we calculate the mean and the standard deviation. After that, just a normal CDF to find area. Right. So with that, we finish section 8.2 here. As always, thank you for watching, and see you in another video in statistics.